Welcome, dear dreamer, to the Sleepy Professor, a quiet corner of the night where the day can finally loosen its grip and drift softly away. Tonight, we'll wander gently beyond our skies, into a realm where whole galaxies drift through space, and sometimes, ever so slowly, they brush against one another in a delicate, endless embrace. Before we begin, may I ask, where are you listening from this evening? Perhaps you are curled beneath the covers, resting easily on the sofa, or gazing quietly into the deep night. However you've arrived here, I'm grateful you're with me. If these gentle explorations bring you comfort, a like and a subscribe would mean more than you know, and for those already part of this calm voyage, thank you for choosing to float with me through the stillness of the universe. I promise to tread softly, not to keep you awake. But should your mind linger with me a little longer, you'll leave with new wonders, tucked carefully into the folds of your dreams. So, as your eyes grow heavier, let us begin our journey. After all, what truly happens when galaxies drift together? Collisions in the cosmos may sound fierce, yet they unfold on timescales so vast, so unhurried, they are less like crashes and more like a graceful cosmic waltz. Galaxies, immense rivers of stars, gas, and dust, are never still. They move, guided by the unseen threads of gravity, drawn slowly into encounters that reshape them over billions of years. Tonight you'll discover how these quiet gatherings unfold, what becomes of the stars and planets gently carried in their embrace, and how black holes and dark matter play their part in this serene dance. We will even look ahead to a faraway tomorrow when our own Milky Way will join hands with Andromeda, a meeting written into the fabric of the universe long before Earth was born. These stories are not hurried. Like the galaxies themselves, we drift slowly, pausing to notice the soft beauty of each step along the way, because within the great collisions of the heavens lies a gentle truth that change, no matter how immense, can still be tender and profoundly creative. If you could float back far enough, beyond the glow of our solar system, beyond the faint twinkle of the nearest stars, you would see the universe is not scattered carelessly. It is arranged in vast, glowing cities of light. These are galaxies, immense sanctuaries, bound together by gravity, each holding hundreds of billions of suns, swirling clouds of gas, drifting veils of dust, and that mysterious invisible presence called dark matter, outweighing everything we can see. Galaxies are not little ornaments scattered across the sky. They are the foundation stones of the universe, vast archipelagos drifting quietly in an endless cosmic sea. A galaxy is less a single being, and more a hushed community of light. Imagine a city at night, seen from high above, each glowing window a star, each street a pathway of light. Together they weave a pattern, soft and endless. A galaxy is much the same, only stretched across a scale the human mind can barely hold. The Milky Way, our home, is a barred spiral galaxy, with perhaps 200 to 400 billion stars. Around many of those stars, planets move in their quiet orbits, and around some of those worlds, perhaps in the stillness, life stirs. Yet even in all this vastness, a galaxy is not chaos. It is a single wheel, turning gracefully around its heart. What holds it together? Gravity, the quiet architect of the cosmos. It is the unseen hand that prevents the stars from scattering into the dark. Galaxies remain whole because their combined weight bends the fabric of space, drawing stars, gas, and dust into a gentle embrace. But the glowing material we see, the stars, the clouds, the shining veils of nebula, is only a fraction of the story. Hidden among it all is dark matter, an invisible framework making up most of a galaxy's mass. Though we cannot see it without it, galaxies would unravel, spinning apart like ribbons in the wind. Galaxies themselves come in many shapes, each with its own quiet personality. The most well-known are spirals, graceful disks, their long arms curling outward like delicate pinwheels of light. These arms are not solid, but waves, waves that coax gas into collapsing, where new stars are born, giving spirals their shimmering blue-white glow. Our Milky Way belongs to this family, its center crossed by a luminous bar of stars. When viewed from afar, spirals appear breathtaking, as though the universe itself had drawn swirls and whirls across the darkness, doodling on the largest canvas imaginable. Then there are the ellipticals. They are quieter, smoother, like glowing ovals of golden light. They carry fewer clouds of gas and dust, meaning they birth few new stars. Their stars are older, their light warmer, their histories long. Many of the largest galaxies in existence are ellipticals, swollen giants that grew by merging with others, time after time. They are the elders of the galactic family, less ornate perhaps, but holding the weight of ages within their glow. And then, the irregulars. These galaxies do not follow neat shapes. They are the rebels of the universe, shaped by gravitational encounters, collisions, or turbulent pasts. Some are small, some surprisingly vast, but all are unpredictable. Where spirals and ellipticals can be gently catalogued, irregulars remind us that not everything in nature follows a simple pattern. Astronomers also notice that galaxies are grouped by size. There are the giants, holding trillions of stars, and the dwarfs, with only a few billion. The dwarfs, though smaller, are the most common, scattered like cottages beside the skyscrapers of spirals and ellipticals. Even our Milky Way is not alone. It is attended by smaller companions, such as the large and small Magellanic Clouds. From the southern hemisphere, they appear as soft, misty patches of light, like smudges on the canvas of the night. In time, these companions may drift into the Milky Way, slowly absorbed into its embrace. Proof that galaxies are not fixed, but ever-changing, participants in a cosmic dance. It is tempting to imagine galaxies as still paintings, hung in the sky, but in truth, they are alive. Stars wheel in great orbits. Clouds of gas drift collapse and flare into newborn suns. Spiral arms ripple gently, like waves moving across a pond. A galaxy is not a frozen picture. It is a living system, unfolding across billions of years. Within it, stars are born, they burn, and eventually fade. Every galaxy is a library of cosmic history. Every star a page, every cluster a chapter, every nebula a story in the making. For all their vastness, galaxies are delicate things. Their spirals, their bars, their graceful disks, all exist only because of a careful balance between gravity, motion, and mass. Disturb that balance and the shapes begin to drift. Collisions, encounters, even the quiet tug of a neighboring system can stretch and twist them, pulling out long bridges of stars or delicate streams of light that arc into the void. Galaxies endure for billions of years, and yet they are never immune to change. They are both fragile and enduring, resilient and ever-shifting, like lanterns of light drifting on a restless sea. When astronomers first turned their eyes to the faint smudges in the night sky, debates stirred. Were these clouds within our own Milky Way, or were they entire universes beyond our own? The answer came in the early 20th century, when Edwin Hubble revealed the truth. Those smudges were galaxies in their own right, each one far beyond the Milky Way, each with its own stars, its own shape, its own story. And now, with the aid of powerful telescopes, we know there are more galaxies in the observable universe than there are grains of sand upon Earth's shores. The number reaches into the trillions, each one a shining city of stars, each one a story waiting to be told. In that immensity, our Milky Way may appear ordinary, but it is anything but. It is a spiral galaxy, about 100,000 light-years across, turning gracefully through space, At its heart rests a supermassive black hole, a hidden giant around which every star, every cluster, every cloud slowly revolves. To us, from our small corner, the Milky Way appears as a pale ribbon of light stretched across the sky, a soft reminder that we live not just within a solar system, but inside a vast and shimmering community of stars. Galaxies are, in their own way, the universe's neighborhoods, but instead of neighbors trading greetings over fences, they share companions and sometimes even merge together, blending into something new. They are social beings of the cosmos, rarely alone, often interacting, always shaped by those around them. Whether spiral or elliptical, giant or dwarf, every galaxy has its own rhythm, its own identity, its own place in the endless dark. To understand galaxies is to glimpse the stage upon which the universe performs its grand play. They are the backdrop and the actors at once, majestic, silent but never still. And though to the naked eye only a few are visible on a clear night, telescopes reveal the truth. Galaxies stretch in every direction right to the edge of the observable cosmos, each one slowly turning in the quiet, each one a glowing lantern against the infinite night. At first glance, the universe may appear motionless. The stars seem fixed in their constellations, the Milky Way arches steadily across the heavens, and the galaxies appear as faint, silent smudges. Yet behind this calm facade is motion constant and ceaseless. Galaxies drift, they swirl, they sometimes collide, all of it shaped by forces both familiar and mysterious. To truly understand why galaxies move and behave the way they do, we must meet the great sculptors of the cosmos: gravity, the ever-present artist, and dark matter, the invisible hand guiding the dance. Gravity is the better known of the two. It is the force we know from everyday life, the reason our feet remain on the ground, and why a fallen cup shatters on the floor. Long ago, Isaac Newton described it in precise terms, showing that the same invisible pull that guides an apple downward also holds the moon in orbit and keeps the planets circling the sun. Later, Albert Einstein deepened the picture, revealing that gravity is not so much a pull as it is the bending of space and time itself. Massive objects curve the fabric of reality, and everything else simply follows those curves. On the grand scale of galaxies, gravity is the patient artist. It gathers matter into clumps, squeezes clouds into stars, and sculpts whole galaxies into spirals, ellipses, or wandering clouds of light. Without gravity, there would be no stars, no planets, no observers here to wonder about them. Gravity is the silent director of the stage, invisible but unyielding. If the universe were a vast sculpture garden, gravity would be the artist's hand, chiseling gently across billions of years. Yet gravity alone cannot tell the full tale. When astronomers carefully measured how stars drifted through their galaxies, they noticed something strange. The stars were moving too quickly. By all visible accounts, the glowing stars, the shining clouds, the misty nebulae, there simply wasn't enough matter to hold everything together. By the math, galaxies should have unraveled long ago, spinning apart into the dark. Something was missing. Something unseen. That missing presence is what scientists now call dark matter. The name may sound mysterious, even a little ominous, but it carries no sinister intent. Dark simply means it does not shine. Dark matter neither emits light, nor absorbs it, nor reflects it. It is invisible to our eyes, detectable only through the quiet tug of its gravity. Current estimates suggest that dark matter makes up about 85% of all the matter in the universe, vastly outweighing every star, every planet, every glowing cloud we can see. Think of a galaxy as a radiant lantern surrounded by an invisible balloon. The lantern is the luminous matter, the stars and dust. The balloon is the halo of dark matter, holding everything together. Without this hidden framework, galaxies would never hold their elegant shapes. They would scatter like sparks from a fire, drifting apart into nothingness. Dark matter is the silent scaffolding of the cosmos, the unseen support that keeps the luminous structures from slipping away. And though dark matter remains one of the universe's most enduring mysteries, we do know what it is not. It is not made of ordinary atoms, not the same kind of matter that makes up you or me or the chair beneath you. It is not merely faint stars, nor hidden clouds of dust. Decades of careful searching have ruled out those possibilities. Instead, it seems to be something entirely new, particles beyond our current understanding, whispering silently through space, unseen. Around the world, scientists have built quiet detectors deep beneath the Earth, hoping to catch the faintest trace of dark matter as it passes through. So far, it has eluded capture, and yet its fingerprints are everywhere, etched into the heavens. Together, gravity and dark matter create the grand design of the universe. They do not act alone, but weave together the great cosmic web. Galaxies gather along invisible threads of dark matter, clustering where the strands intersect, while in between lie vast silent voids. From far enough away, the large-scale universe would look like a three-dimensional web stretched across billions of light-years, galaxies strung along filaments, glowing like beads upon invisible threads, shaped by gravity's gentle hand. But why do galaxies move at all? If gravity holds them so firmly, why do they not remain still? The answer lies in their birth. In the earliest days of the universe, tiny ripples in density gave some regions a small advantage. Those regions drew in more matter, which fell inward along curved paths, gaining both spin and drift. And so, from their very beginnings, galaxies carried motion. Even now, they continue to move, guided by the pull of their neighbors. Our own Milky Way is no exception. It is not resting idly in space. Even now, it is moving toward the Andromeda galaxy at hundreds of thousands of miles per hour. Space is vast enough that their meeting is not immediate. It will take about 4 billion years before the two galaxies embrace. To us, that feels like forever, but on cosmic timescales, it is little more than a gentle pause. Galaxies are not isolated marbles. They are dancers in a grand gravitational ballet, each step influenced by every other partner, and one of the most beautiful outcomes of this movement is the way galaxies interact. Sometimes they brush past one another, their shapes tugged and twisted by tidal forces. Sometimes they collide fully, merging into new forms. Long before their centers touch, gravity begins to pull at their edges, drawing out bridges of stars and delicate tails of light. Gas clouds are squeezed into bright star nurseries, and deep at their hearts, black holes may eventually spiral together into one. What looks like chaos is in fact harmony, the quiet unfolding of natural laws across impossible distances. It is important to remember how patient gravity is. To us, collisions are sudden, violent things. On the scale of galaxies, they are more like clouds drifting together in the sky. The process takes hundreds of millions of years. Entire generations of stars may be born and die in the time it takes two galaxies to merge. The forces are immense, but the pace is serene. And in these vast encounters, dark matter plays its hidden role. When galaxies collide, their visible forms may stretch and distort, but their halos of dark matter pass through one another like two invisible balloons brushing together. These halos, so much larger than the galaxies themselves, guide the outcome of the encounter, shaping the new structure that emerges. For astronomers, such mergers are precious clues, revealing the otherwise invisible architecture of dark matter. From all of this, a quiet truth emerges. The universe is not frozen. It is not a still museum of light, but a living, shifting tapestry, shaped by forces both seen and unseen. Gravity bends the paths. Dark matter holds the frames, and together they create beauty on the grandest of scales. To gaze at a galaxy is to witness this partnership, the balance between what we understand and what remains beyond our reach. It is to see the patient artistry of the cosmos, a design etched not in stone, but in stars. And when we look closely at these forces, we are not just explaining shapes that drift in the night sky. We are uncovering why the universe has a story at all. Without gravity, the gas and dust of the cosmos would never have gathered into suns. Without the quiet pull of dark matter, galaxies would never have held together long enough for planets to form. And without planets, there would be no oceans, no skies, no breath, no thought, no dreamers lying beneath the stars. Every dream owes its existence to these silent shapers of the cosmos. The universe may seem endless, but its tale is told by just a handful of timeless characters, each playing a role older than memory itself. Galaxies may appear as ornaments suspended in stillness, but they are not frozen at all. They are ancient travelers, reshaping themselves slowly across spans of time so vast, even the life of a star feels brief in comparison. To understand galaxies is to step outside the rhythm of human time and wander into an expanse where billions of years unfold like gentle pages of a never-ending story. Every galaxy begins as a faint gathering of matter in the young universe. After the Big Bang, nearly 13.8 billion years ago, the cosmos was a sea of hydrogen and helium, spread almost evenly across the dark. But here and there, tiny ripples appeared, so subtle they might have seemed meaningless. Yet over ages beyond counting, gravity deepened those ripples, drawing matter inward until the first clumps of stars ignited and the first galaxies were born. They were small at first, irregular, glowing with newborn stars. They lacked order, but they carried the promise of what was to come. Gas was abundant, fueling bursts of starlight until over time they grew, shifted and found their forms. Like seedlings sprouting from soil, these galaxies carried the quiet potential for beauty. As eons passed, galaxies evolved. Inside, stars were born, burned and died, seeding the gas around them with carbon, oxygen, and iron, the very ingredients of worlds, oceans, and life. With each generation, their glow softened, from the blue of youth to the golden calm of maturity. Beyond themselves, galaxies were shaped by neighbors. In the crowded young universe, encounters and collisions were common. But these were not sudden events. They were long, drawn-out dances lasting hundreds of millions of years. Stars, separated by vast distances, rarely collided. Instead, the grand shapes of galaxies shifted. Spirals stretched, gas clouds collided, sparking new waves of stars. Two galaxies might merge, not with violence, but with slow grace, until one larger system remained. It is easy to imagine these encounters as destruction, but in truth, they are creation as well. Without collisions, galaxies would never have grown to the immense size we see today. The giant elliptical galaxies that rest at the centers of clusters are monuments built from countless mergers, records of ancient cosmic unions written in starlight. Even our Milky Way has scars of its long journey. Streams of stars still arc across its halo, remnants of smaller galaxies absorbed long ago. And in the far future, our own spiral home will meet Andromeda, not with sudden chaos, but with a long, slow blending until they become one. This cycle shows how galaxies live, resilient and enduring. A spiral may one day fade, losing its gas, growing quieter, settling into a rounder, gentler form. Stars grow old, their light dimming. The galaxy itself becomes quieter, glowing softly like a city at twilight. Time on this scale is beyond imagination. A galactic collision may last hundreds of millions of years. By comparison, the entire span of human history from the first villages to the cities of today is but a breath. Even the age of the dinosaurs fills just a single chapter in the life of a galaxy. Galaxies do not hurry. They drift and change with patience, and in their patience there is comfort. For if the universe allows such vast cycles to unfold, then it also holds space for every fleeting story, from the quiet of one human breath to the slow arc of a galaxy. To gaze at a galaxy is to look into deep time. Its light has travelled for millions of years to reach our eyes, carrying with it a memory of ages past. And still, the galaxy moves onward, slowly evolving, too vast to notice our short lifetimes passing. Galaxies are not just stars. They are living chronicles, silent monuments to the patience of the cosmos. And when we hear the phrase galaxies colliding, our minds may leap to chaos, to explosions, to stars crashing, and worlds scattered into the void. It sounds like a story of violence, but in truth, it is far softer. Galactic collisions are not sudden endings, but slow, graceful transformations. Not explosions, but gentle reshaping, stretched out across the endless night. An important truth is that stars almost never collide. Even when their galaxies do, it seems impossible, doesn't it? After all, a galaxy contains hundreds of billions of stars. Shouldn't they smash together like cars on a crowded road? Yet the answer lies in scale. Stars, though immense on their own, are tiny compared to the vast spaces that separate them. Imagine 2 grains of sand placed miles apart. That is the spacing of stars inside a galaxy. So even when galaxies drift through one another, direct star-on-star collisions are vanishingly rare. What really happens is far more delicate. Gravity tugs at the galaxies, pulling and stretching their shapes. Long, elegant tails of starlight unfurl like ribbons, sweeping across hundreds of thousands of light years. Great clouds of gas far larger than any star do collide, and when they do, something remarkable unfolds. The gas compresses, collapses under its own weight, and ignites new generations of stars. Collisions do not usually destroy stars. They give birth to new ones, lighting the darkness with sudden brilliance. These starbursts shine fiercely but briefly, before fading into quiet memory. In this way, collisions enrich the universe not with ruin, but with renewal. The very oxygen you breathe, the iron in your blood, the carbon in your body, all trace back to such stellar cycles. Galactic encounters accelerate this alchemy, feeding the cosmos with the ingredients for life. The stars themselves are rarely harmed, though their paths may be gently shifted. Some are flung into sweeping arcs, others drawn inward to the center. A planet circling one of those stars would feel almost nothing. Only over millions of years would the constellations of its night sky begin to change. One of the most enduring myths about galactic collisions is that they are violent wrecks. The truth is calmer. Galaxies pass through each other like phantoms, their stars mostly untouched, their gas clouds quietly glowing with new life. Even the word collision misleads us, for what unfolds is more like a dance, a patient blending of forms. When 2 galaxies of equal size merge, their elegant spirals may be torn apart, leaving behind a softer, rounder, elliptical shape. Over billions of years, the chaos settles into serenity. Each elliptical galaxy we see today is a quiet monument, carrying within it the memory of ancient unions, scars healed into new form. Sometimes the dance is unequal. A great galaxy gently consuming a smaller companion. Astronomers call it galactic cannibalism, though it is far less violent than the name suggests. The smaller system is stretched thin, its stars and gas absorbed, leaving behind faint streams of light, ghostly trails marking where it once was. Even our own Milky Way is doing this now, pulling in its smaller neighbors, weaving them into its grand spiral. Gas clouds play a special role here. Unlike stars, they are vast enough to collide directly. When they do, they lose energy and sink toward the galaxy's heart, sometimes feeding the supermassive black hole hidden there. For a time, that black hole may awaken, glowing brighter than the stars around it. What we see from Earth is a quasar, an astonishing beacon, shining across the universe. But all of this unfolds slowly, far beyond the pace of human time. A galactic merger takes hundreds of millions, even billions of years. Civilizations could rise and fall on distant worlds without ever noticing the change. To us, these encounters look like frozen pictures. A bridge of stars here, a tidal arc there, moments in a film that plays across eternity. What seems to us like destruction is, in truth, creation in disguise. Stars continue their quiet burning. Gas ignites in bursts of new life. New shapes emerge from old ones. Collisions are not disasters, they are transitions, soft steps in the endless choreography of the cosmos. And so, when two galaxies come together, what emerges is not destruction, but something resembling art. Gentle streams of light unfurl across the heavens, stretching like slow brushstrokes across a canvas of night. Bridges of starlight extend softly from one galaxy to another, like glowing handshakes reaching out in the quiet dark. Each encounter whispers a reminder that even in the immense vastness of space, transformation can unfold slowly, gracefully, and with a beauty that feels eternal. These patterns, painted in strokes far larger than our imagination, are why galactic collisions are often called ballets, not crashes, but performances measured, deliberate, haunting in their serenity. One of the most mesmerizing details in these dances are tidal tails, long ribbons of stars and gas that stream outward from colliding galaxies. They can stretch for hundreds of thousands of light years, pulled into elegant arcs by the immense gravity of their partners. To those who watch, tidal tails drift like glowing ribbons into the dark, their curves echoing the soft flow of gravity itself. Some eventually curl inward, falling back into the merged galaxy, while others drift endlessly subtle traces of encounters that linger for billions of years. Bridges are another quiet wonder of these meetings. They appear as luminous threads pulled gently between galaxies, like trails of starlight linking two islands across a dark cosmic sea. These bridges are the visible evidence of gravity at work, a slow tug-of-war traced in stars and dust. Over time, they collapse back into the galaxies that birthed them, but while they exist, they give the impression of two galaxies reaching out, almost touching hands. Sometimes, galaxies also leave behind streams of stars as companions are gently pulled apart. These streams, faint but stretching far, curl around galaxies like delicate halos, or loop across the sky with dreamlike curves. Even our own Milky Way carries these traces, remnants of small galaxies absorbed long ago. They are like lingering echoes of earlier dances, still drifting quietly through the dark. Through telescopes, the beauty of these features deepens. In ultraviolet light, bursts of newborn stars sparkle within tidal tails. In infrared, warm clouds of dust glow softly, stirred by hidden stellar nurseries. Radio telescopes map the invisible hydrogen gas stretched across unimaginable distances, tracing unseen rivers that feed the birth of new suns. Taken together, these perspectives remind us that what seems chaotic is, in truth, a composition, each wavelength adding another gentle note to a cosmic lullaby. Computer simulations add yet another layer to the picture. With modern computing power, astronomers model galaxies as millions of points, each one standing for a star, a cloud of gas, or a portion of dark matter. When these models are set on a course to meet, the resulting motion is astonishingly lifelike. Spirals unfurl, tails sweep outward, and glowing bridges connect them just as in real space. These simulations not only teach but mesmerize, allowing us to watch billions of years drift by in moments. They reveal the universe's rhythm, its slow sways and careful turns. Galaxies overlap and retreat, bend and return, like dancers sharing a timeless duet. Eventually they settle together into a single new form, the turbulence fading once more into calm. Seen this way, their collisions are not frantic events, but deliberate, graceful movements. Tidal tails curl like strokes of calligraphy, brushed across the dark. Loops of stars form letters. No one can read, but everyone can feel. Bridges curve like the arms of dancers mid-motion. There is no audience, no performance intended, yet the spectacle stirs something within us. The same quiet awe we feel when standing before great works of art. Their slowness is part of their beauty. Unlike the word collision suggests, there is no sudden crash, no violent end. Galaxies move with deep patience. Their embraces unfolding across hundreds of millions of years. To anyone watching from afar, the sight is serene, not chaotic. Even at their most dramatic, they sway with a rhythm that mirrors the stillness of the cosmos itself. Consider the antennae galaxies, among the most famous examples. To us on Earth, they appear as two spirals locked gently together, their bright hearts glowing, while long tails of stars sweep outward like soft antennae. Within those tails, clusters of new stars shimmer, born from compressed clouds of gas. The system radiates energy, yet it feels poised, elegant, almost tender. The antennae remind us that even in upheaval, the universe produces beauty. Or the cartwheel galaxy, its strange ring formed when a smaller galaxy passed through the heart of a larger one. The result was a wave, like ripples moving across water, pushing gas and stars outward in concentric circles. In that ripple, new stars ignited, glowing across the ring and giving the galaxy its name. Science calls it reorganization on a colossal scale. To the eye, it looks deliberate, like a design etched into the night by a careful hand. What makes these forms even more haunting is their impermanence. Tails will fade, bridges collapse, streams disperse. The shapes we marvel at now will dissolve within a few 100 million years, a fleeting moment in the lifetime of galaxies. That we are here to witness them at all is a quiet gift, a reminder that beauty need not last forever to be meaningful. Perhaps the most calming way to imagine these encounters is as a dance floor spread across the universe. Galaxies do not hurry. They glide. Ribbons of stars trail behind them like silk, curling in slow arcs as gravity guides their steps. From afar, the view is tranquil, meditative, like watching the cosmos itself sway to a lullaby beyond time. This galactic ballet is a reminder of perspective. Up close, it is full of turbulence and bursts of light, but step back and you see only grace. The same moment can be chaos or beauty, depending on where you stand, and in that duality lies the wonder that physics can write poetry in the stars. Across the silent reaches of the cosmos, galaxies drift, approach, and sometimes embrace. They collide, they merge, and they reshape one another in slow dances that last billions of years. Among these countless interactions, a few stand out familiar to both astronomers and dreamers like portraits framed in the sky. Some look as though they are caught mid-embrace. Others carry the scars of encounters long past. If galaxies kept stories the way we keep books, these would be the chapters most often revisited, their beauty lingering across the ages. One such wonder is known as the antennae galaxies. They drift 45 million light-years away, yet in the quiet of night, they feel strangely close. To our eyes, they look like two spirals paused mid-dance, their hearts overlapping in a glowing center, their long arcs of stars stretching outward like luminous arms. These arms are not mere decoration. They are rivers of stars and gas drawn out by gravity's unseen pull. Within those tidal streams, entire clusters of new stars are born, their youthful blue light sparkling like fresh embers in the dark. A collision that seems violent has, in truth, given rise to a quiet, radiant firework, show that will last for hundreds of millions of years. Observed in visible light, in radio waves, in ultraviolet and infrared, the antennae reveal themselves as a canvas of activity, a place where both chaos and creation breathe side by side. In time, the two spirals will settle into one, an elegant elliptical galaxy, calmer and older. But for now, we witness them in their most dramatic moment, frozen mid-step, their beauty suspended across the heavens. Another icon, softer but no less striking, is the whirlpool galaxy Messier 51. About 23 million light-years away, it unfurls its spiral arms face-on toward us, almost too perfect to believe. Each arm winds outward in gentle, flawless symmetry, carrying billions of stars upon its path. Yet the whirlpool does not dance alone. A smaller companion galaxy circles nearby, pulling gently at the spiral's arms, reshaping them, and sparking waves of new star formation. Seen through the Hubble telescope, its arms are painted with delicate dust lanes, strokes of shadow weaving through light. Pink regions glow where massive stars are forming, while blue clusters shimmer where young stars have only just emerged. The smaller companion, though faint compared to its partner, leaves its mark tugging material outward, exaggerating the spiral's beauty. It is as though the whirlpool were a serene dancer, and the companion a playful partner, stirring the performance into something even more captivating. One day, the two will merge. For now they remain in a delicate balance, their union unfinished, their beauty at its most radiant stage. Then there is the Cartwheel Galaxy, perhaps the most unusual of them all. About 500 million light-years away, it floats in the constellation of Sculptor. Unlike any ordinary spiral or ellipse, it looks instead like a glowing wheel, an outer ring of stars circling a bright hub, connected by faint spokes of light. Its shape was not carved by chance, but by encounter. Long ago, a smaller galaxy is believed to have passed directly through its center, sending ripples outward as a stone does across water. Those ripples pressed gas together, igniting bursts of star formation along the expanding wave. The bright ring we see now is the crest of that ripple, alive with newborn stars. It is both fragile and extraordinary, a fleeting sculpture in the cosmos shaped by motion, impact, and time. The antennae, the whirlpool, the cartwheel, each carries its own personality, each tells its own story. Together they show us that when galaxies meet, the results are never the same. Some become radiant with new stars, others twist into unexpected forms, and still others settle into quiet giants. These galaxies have captured not only scientific curiosity, but also human imagination. They appear in books, in classrooms, on screensavers and posters. They are remembered not just for their scale, but for their artistry. And yet, their beauty is only a fleeting pause in time. The antennae will one day drift into quiet harmony. The whirlpool will slowly fold its companion into its luminous arms. The cartwheel's glowing ring will fade as its young stars grow old and dim. These spectacles we admire tonight are simply moments, captured in the endless flow of cosmic history, frozen for us to marvel at, but already on their way to becoming something else. And still, even a moment is enough. For in these fragile displays we are reminded that the universe is not still, it is alive, breathing, reshaping, and creating new wonders with every passing age. In their light, we glimpse more than science. We glimpse poetry written in constellations, elegance etched by gravity's hand, and the quiet artistry of the cosmos itself. At the centers of nearly every great galaxy lies a secret, an object so heavy, so dense, that not even light can escape its pull. These are the supermassive black holes, cosmic giants millions or even billions of times heavier than our Sun, yet occupying a space smaller than our solar system. Invisible to our eyes, they reveal themselves through the whispers of their influence, stars flung into dizzying orbits, clouds of gas heating until they glow, and sometimes entire galaxies lit like lanterns as matter swirls into their depths. Though galaxies are vast collections of stars, gas, and unseen dark matter, their hearts are anchored by these compact titans, steady gravitational centers binding it all together. The link between galaxies and their black holes is profound, almost like a hidden partnership. Astronomers have discovered that the mass of a galaxy's central black hole is tied closely to the mass of its surrounding stars. The larger the bulge, the larger the black hole. It suggests they grow in unison, feeding one another slowly across the ocean of billions of years. And when galaxies collide, this partnership faces its greatest test. Imagine two galaxies on a slow-motion collision course, each carrying a black hole at its center. As they drift closer, their stars stretch into new patterns, their gas flows into spirals, their shapes warp like soft clay pulled by invisible tides. Over millions of years, the galaxies overlap, their hearts inching ever closer until the two black holes find themselves in the same cosmic neighborhood. At first, they circle distantly, two silent giants locked in an orbit around each other. But gravity is patient. With every turn, they lose energy. With every orbit, they spiral closer, pulled into a slow, inevitable embrace. What begins as two separate centers of gravity becomes a binary black hole system, two colossal beings bound together. This dance may last for millions of years, but it does not last forever. As they orbit, they disturb the very fabric of reality itself, sending ripples through space and time, gravitational waves. These waves radiate outward like circles across a pond, carrying energy away, drawing the black holes closer and closer together. As they near the final stage, their orbits quicken, spinning faster, stronger, until they whirl at nearly the speed of light. Then at last, they merge, collapsing into a single, larger black hole. For the briefest instant, the universe flares with unimaginable power, more energy than all the stars in the visible cosmos shining together. Yet almost none of this brilliance comes as light. It comes as those ripples in space itself, spreading outward across eternity. Gravitational waves are one of the most astonishing predictions of Einstein's theory of relativity. They are not light, nor sound, but the universe itself stretching and squeezing as the waves pass by. Here on Earth we are bathed in them, constantly faint whispers from distant collisions, but they are so subtle that we do not feel them. Detecting them requires tools of impossible delicacy, instruments that can measure distances smaller than a proton's width. In 2015, humanity finally touched one of these ripples. The Laser Interferometer Gravitational Wave Observatory LIGO recorded the faint signature of two black holes colliding more than 1 billion light-years away. The signal lasted only a heartbeat of time, but it was enough. It proved beyond doubt that gravitational waves are real. It proved that black holes, once thought of as almost imaginary, not only exist but crash together, reshaping the universe in silence. Since then, dozens more signals have been heard, each one a whisper from the deep, carrying the story of massive objects colliding in the dark. When galaxies merge, their central black holes are destined to follow. First, they sink toward the merged center, slowed by the collective pull of stars and gas. Then, they orbit one another in a long duet, until at last, gravitational waves drain away their final energy, and they collapse together. These moments are both challenge and gift for astronomers. The challenge lies in catching them, for the signals are faint, barely noticeable against the vast background of the universe. But the gift is profound. Gravitational waves allow us to listen to the cosmos, not just see it. And what they reveal is extraordinary. The merging of supermassive black holes is expected to create some of the deepest, most powerful gravitational wave signals of all. To capture them, future observatories like LISA, the Laser Interferometer Space Antenna, are being designed. Unlike ground-based detectors, LISA will float in space, its instruments tuned to the slow, deep rhythms of giants spiraling together across months and years. With it, we will hear the low, resonant hum of supermassive black holes joining, offering new insights into how galaxies grow, how black holes feed, and how gravity itself behaves under the most extreme conditions. Black holes embody a strange duality. They consume, they destroy, they erase. Yet they also create, guiding the shape of galaxies, igniting star formation, and lighting up the universe with the glow of falling matter. When two supermassive black holes merge, they do not end, they begin again, forming a new center of gravity, a fresh anchor for the galaxy reborn. Their joining sends ripples outward that will travel for billions of years, carrying the memory of their embrace across the cosmos. The thought of such immense events may sound frightening at first, yet their scale is so vast, so drawn out, that we remain entirely untouched. Even when our Milky Way eventually drifts into Andromeda, long into the distant future, the black holes at their centers will slowly spiral together and merge, yet Earth will never be endangered. By that time, our sun will have already burned out its last light, and our world may no longer exist as we know it. The encounter will be breathtaking. Yes, but only upon the stage of the universe, far away and never close enough to trouble us. And so the story of black holes is not one of chaos, but of patience. Their dances unfold not in years or centuries, but across millions upon millions of quiet nights. Orbits slowly narrow, gentle ripples spread outward, and at last, two titans become one, leaving behind a single silent heart at the center of a galaxy and a memory written softly into the fabric of space itself. These invisible giants merging are a reminder of beauty even in the darkest corners of the cosmos. To picture it more gently, imagine two dancers gliding in circles, drawing a little closer with each turn. The floor beneath them hums with the faintest vibrations until, finally, they meet in one slow, graceful step. That is what galaxies carry deep within their centers, not just stars and gas, but hidden performers whose movements send faint ripples across reality itself. And while our eyes may never see such a union directly, our instruments now allow us to feel the soft echoes of their dance, humming faintly across the vast sea of space. When galaxies collide, the images caught by telescopes look wild and tangled spirals distorted, great arcs of glowing gas flung outward like ribbons of light. Yet if you pause and shift your gaze from the grand view to the experience of a single star, the story changes entirely. For most stars, a galactic collision is not violent at all. It is more like a slow drift, a gentle reshuffling of neighborhoods within the cosmic city. The change is so gradual that even the longest-lived beings on Earth would never notice it happening. This is because of the sheer scale of space. The stars within a galaxy are separated by such incredible distances that even when entire galaxies overlap, the chance of two stars colliding is almost nothing. If the Sun was shrunk to the size of a marble, the nearest star, Proxima Centauri, would be another marble placed hundreds of kilometers away. That is the depth of emptiness we are speaking of. Galaxies may look dense from a distance, but in truth, they are mostly made of space, mostly made of silence. For a star, then, a galactic collision is not like a crash at all, but more like being one grain of sand carried in two drifting winds, passing through each other without touching. What does happen is subtle. The star's orbit gently shifts. Some are drawn outward, stretching into long luminous tails. Others drift inward, spiraling closer to the heart of the galaxy. But these changes unfold slowly, over millions of years. A star that once circled in a neat loop might find itself on a wider arc or wandering toward a quieter corner of the galaxy. Yet to the star itself, nothing feels different. It simply continues on, following the gentle script of gravity around it. For stars with planets in tow, the calm is even greater. The sun's pull on Earth, for example, is far stronger than any passing influence from another galaxy. Earth drifts 93 million miles from its parent star, and within that bond, distant forces hardly register. This means that when galaxies collide, solar systems remain intact, planets still circle their suns, seasons still pass, and if life exists there, it may continue without ever knowing that the galaxy around it is slowly being reshaped. Yes, there are rare exceptions. On occasion, two stars may wander close enough to tug at one another, perhaps unsettling the orbits of their planets. A lonely world might be flung away into the dark, drifting endlessly as a rogue planet without a home. But such encounters are vanishingly rare. For the overwhelming majority of solar systems, galactic collisions are quiet affairs, so subtle that no one within would ever know they were happening. Sometimes, though, stars are pulled into great arcs, long tails of light that trail behind their galaxies like flowing banners. A star that once lived near the bright center might find itself cast into the quiet outskirts, circling alone for billions of years. Yet still, the star itself does not break or fade. Its light continues to burn, steady as always, indifferent to the grand ballet unfolding around it. This quiet endurance of stars is humbling. Human lives pass in decades. Stars measure their lives in eons. They persist through upheaval, shining calmly while galaxies twist and merge. To imagine the perspective of a star is to imagine patience so vast that change feels like stillness. And in that stillness, the fusion at its core continues without pause, a lighthouse shining across the cosmic night. Even the most powerful upheavals, the merging of black holes at the centers of galaxies, barely ripple outward far enough to disturb the stars on the edges. Their lives remain untouched, their light steady, while the centers of galaxies remake themselves. The universe is wide enough, and galaxies spacious enough, that what appears spectacular from afar is, for most of its stars, a quiet background hum. Perhaps this is the most gentle lesson of all. The universe's greatest events often arrive not with violence, but with quiet whispers. Galaxies may drift together, they may even collide, yet the stars within them continue to shine. They keep glowing, patient and steady, as if reminding us that beauty does not always come from noise or sudden change. Sometimes it is found in constancy, the simple act of shining softly across the ages. When galaxies merge, their graceful shapes bend and stretch, curling into ribbons of light. Spirals unravel into delicate streams and long bridges of stars form, connecting one galaxy to the other. But the most profound transformations are not in the stars we already see. They happen in the hidden clouds of gas and dust that drift quietly between them. These invisible veils, glowing gently in radio and infrared light, carry the raw material of creation. When galaxies meet, these clouds are stirred and pressed together, and from that stirring, new suns are born. Gas and dust may sound simple, like the faint mist in the air, or a layer of particles on a forgotten shelf, but in the cosmos, they are sacred ingredients. Interstellar gas, made mostly of hydrogen, fills galaxies like a breath that never ends. Tiny grains of dust, carbon, silicon, and other elements scatter light and paint the soft outlines of nebulae. Together, they are the fertile soil of the stars. Without them, galaxies would fade into quiet collections of aging suns. With them, galaxies become nurseries, alive with new beginnings. A galactic meeting is like a gardener tending soil. Clouds that once floated in silence are suddenly pressed together by invisible hands of gravity. They fold inward, collapsing into knots until each knot grows hot and dense enough to burst into fusion. New light flickers into being. Astronomers call these luminous seasons starbursts, moments when a galaxy kindles stars at astonishing rates, far faster than usual. A once quiet galaxy can blaze with clusters of bright, youthful suns, their short lives burning blue and brilliant before they fade. In those brief lives, they transform everything around them. They warm the gas nearby, they scatter heavy elements into space, and they prepare the seeds for future stars, planets, and perhaps even life. Starbursts are not simply fireworks, they are renewal. They drape galaxies in glowing hues, soft pinks and deep reds, hydrogen clouds, illuminated by the breath of newborn suns. Through the eyes of a telescope, colliding galaxies become gardens, with luminous patches scattered like blossoms across their forms. Each bloom is a cluster of new light. Nebulae play their part as well, the radiant clouds of color we know from images like the Orion Nebula. In colliding galaxies, these clouds ripple with energy. Shock waves pass through them, shaping delicate filaments and igniting waves of birth. Seen from Earth, their colors glow in soft shades, reds from hydrogen, greens from oxygen, blues from helium. They are the universe's painted gardens, alive with motion yet calm in their beauty. It is a cosmic cycle of loss and renewal. Old stars end, scattering their elements back into space. Collisions stir that material into new shapes, ready for fresh beginnings. Destruction and creation flow into one another, inseparable, like tides of light. A single star-forming region may cradle thousands of new suns, some steady and long-lived, others brief and brilliant, a few perhaps surrounded by planets with the quiet potential for life. All of this unfolds across millions of years. To us it seems like silence, but in truth, it is the steady breathing of the universe. Collisions guide gas inward, feeding central black holes, kindling quasars and igniting new regions of light. But starbursts cannot last forever. The fuel is spent, and the blaze settles into calm. A galaxy, changed, enters a quieter phase, its soil resting until the next stirring begins. To witness such a moment is to glimpse the universe mid-thought, caught in one of its rare bursts of vitality. Most galaxies spend their lives in stillness. To find one aflame with birth is to see renewal written in light. The cosmos wastes nothing. Every particle, every wisp of dust is drawn into the cycle. Even in collisions, what seems like chaos from afar, the universe is simply turning its soil, planting seeds and waiting for new blossoms. And here, from our quiet little world, we look outward across millions of light years and see this truth. Through the eyes of telescopes, glowing arcs appear, jeweled clusters shimmer, colors are brushed gently across the dark. They whisper that the universe is not only vast, but endlessly fertile, always breathing, always renewing, always weaving fresh strands of light. So when our gaze rests on colliding galaxies, we are not only watching endings, we are watching beginnings. We are witnessing the gentle promise that even in upheaval, the universe bends back toward beauty. These encounters are not simply disruptions, but acts of cultivation. They remind us that the grandest structures of the cosmos, too, participate in renewal. Galaxies sow new generations of stars that will burn for billions of years. Like gardens tended slowly by unseen hands, they bloom through their collisions, ensuring the universe never grows barren, but remains alive with light. The spectacle of colliding galaxies often draws attention to the drama, the great arcs of starlight, the glowing nurseries of young suns, the brilliant flares of black holes feeding. Yet this drama is only the beginning of the story. Collisions are fleeting on cosmic timescales. After the fireworks fade and the starbursts exhaust their fuel, a quieter phase begins. Slowly, chaos softens into calm. What starts as a turbulent dance settles into a single unified form, scarred by its history, yet shining with new stability. The aftermath is messy at first. Long tidal tails stretch far into space. Stars are flung outward in graceful arcs. Gas clouds collide, glowing with the heat of newborn clusters. But over hundreds of millions of years the violence eases. Tails thin and dissolve. Bridges collapse. The outlines of the original spirals blur until they are gone. Gravity, patient and persistent, pulls everything inward, gathering the fragments into balance. In the end, the delicate spirals are almost always erased. Their thin discs, once so graceful, cannot survive the violent stirring. What remains is different an elliptical galaxy, rounder, smoother, more settled. Its stars are no longer arranged in sweeping arms, but spread in every direction, filling a gentle sphere of light. The glow shifts toward warmer colors, for the youngest blue stars fade quickly, leaving behind the steady radiance of older suns. This new form carries the weight of maturity. The galaxy has weathered turbulence, endured renewal, and emerged as something quieter, more enduring. Elliptical galaxies are like elder beings of the cosmic family. They do not blaze with the restless energy of youth. Their star-forming gas has been consumed or carried away. Instead, they shine with the steady presence of ancient populations, soft, enduring, dignified. The roar of collisions fades into silence, the brilliance of starbursts into a golden afterglow. These galaxies enter a long twilight, glowing softly against the blackness of space, content to shine as they are for billions of years. In great clusters, where collisions are most common, elliptical giants dominate. Some swell to unimaginable scales, holding trillions of stars. They act as anchors, quiet monarchs of their realms, surrounded by smaller companions. Each one is a living archive, a quilt stitched together from countless past unions. Their calm light carries the memory of all the energy that came before. Yet this calm is not absolute stillness. Stars continue to orbit, black holes still breathe faintly in their hearts, and the occasional stream of matter drifts inward. But compared to their younger days, these galaxies are far more settled. Their rhythm is slower now, their glow more measured, their essence a balance rather than a blaze. Their silence is not emptiness, it is contentment. From our human lives, this is a soothing lesson. Just as galaxies burn with chaos and then find their way into calm, so too do we. The elliptical galaxies glowing in the night remind us that upheaval can give way to peace, that storms eventually dissolve into clarity. Their quiet presence is a testament to endurance, to the slow work of gravity shaping chaos into serenity. This transformation is guided by simple physics. Stars are scattered into random paths, no longer aligned into neat spirals, but moving freely in every direction. Gas is consumed in starbursts or expelled by winds and black holes. With little fuel left, star birth slows, leaving galaxies to glow with the light of aging stars. Their brilliance dims, but their stability deepens. They have reached a kind of equilibrium. Some of the largest ellipticals in the universe are thought to be the final chapters of this process, the end result of countless collisions, stretched across cosmic time. Their enormous size, their smooth glow, their silence, all tell a story of lives once restless, now at rest. To look at them is to glimpse the stillness of maturity, the quiet grandeur that comes after long journeys. And even here, in their quiet stillness, life carries on. Stars continue their long journeys, some fading gently into white dwarfs, some collapsing into the dense silence of neutron stars, and others vanishing into the deep pull of black holes. Clusters of stars drift like companions, circling slowly, while central black holes stir only when a delicate stream of matter wanders too close. Yet, through all of this, The rhythm remains calm, steady, unhurried, assured. If spiral galaxies are like youthful dancers, bright and swirling with energy, then ellipticals are the elders measured, enduring, glowing softly, as though holding a lantern in the long twilight of time. They are like statues after the music has faded, motionless yet radiant, standing quietly as centuries dissolve around them. This stage of stillness may last for trillions of years, stretching far beyond the lifespan of the universe as we see it now, long after the spirals have merged and the birth of new stars has slowed to silence. These elliptical galaxies will remain, glowing faintly with the light of aging suns. They are the survivors, the patient watchers of the darkening cosmos. Their calm is not emptiness, but completion. It is a stability born of every change that came before, a lasting balance across unimaginable spans of time. To reflect on them is to glimpse the universe not only as a place of energy and motion, but also as a sanctuary of rest. For even cosmic storms end in quiet skies, and every great outburst eventually settles into stillness. And so, in the faint glow of elliptical galaxies, we find a lesson that endurance has its own beauty, that after turmoil comes peace, that the universe, like life itself, contains seasons of both storms and serenity. If you lift your eyes toward the constellation Andromeda, you may notice a dim smudge of light. To the unaided eye it seems almost trivial, like a cloud drifting in the distance, or even a faint blur in vision. Yet, that soft blur is no flaw of sight, but the Andromeda galaxy itself, our nearest great neighbour, a spiral like the Milky Way, alive with hundreds of billions of stars, and it is not just nearby, it is moving steadily toward us. Now, before any urgency stirs, it helps to remember that this quiet encounter will not arrive for another 4 billion years. By then the Earth's continents will have shifted beyond recognition. The sun will burn brighter than it does today, and humanity as it is now will either be long gone or living in ways we cannot yet imagine. The timeline is so vast, it is like being told a breeze will arrive after 1,000 generations of stars are born and gone. Yet still, the thought remains our Milky Way and Andromeda are destined to meet. Astronomers have traced Andromeda's path. It moves toward us at around 110 kilometers per second, a number that may sound swift, but across the 2 million light-years between us, it is no more than a drifting approach, as unhurried as two ships gliding across an endless ocean. For now, the distance is so great that the meeting seems endlessly postponed, and yet the outcome is certain. When the encounter finally begins, the sight will be breathtaking. Andromeda will swell in our skies, first as a larger blur, then as a shining disk, and eventually as a luminous structure dominating the heavens. Over millions of years, the two galaxies will pass through one another, their stars slipping by unharmed, like ghosts sharing the same air. For though galaxies collide, their stars are separated by distances so vast that direct collisions are rare. The beauty will not be in sudden crashes, but in the stretching of shapes, in luminous arcs of stars drawn out like ribbons, and in the birth of new stars where clouds of gas are gently compressed. The merger will not be a sudden strike, but a slow embrace. The galaxies will drift through each other, then fall back again, weaving together in tidal tails and arcs of light. Gravity will bind them, pulling them closer in repeated passes, until after billions of years they rest as one. The result, astronomers believe, will be a single larger elliptical galaxy, rounder, smoother, and more serene than either of its parents. Some even give it a name, Milky, a gentle fusion of the two. And what of our solar system? Most likely it will survive, yet its place within the galaxy could shift dramatically. The sun and its planets may be carried outward into the galactic edges, or drawn closer to the center, perhaps even placed along one of those tidal streams, drifting like a bead of light within a vast ribbon of stars. For any descendants of humanity who might remain, the night sky would be utterly transformed. Familiar constellations would vanish, replaced by new unknown arrangements. Imagine looking up to see not one spiral but two woven together, their arms crossing in radiant threads of starlight. Starbursts would shimmer, outshining the galaxies beyond. The heavens would no longer feel still but alive with unfolding change. Yet the motion would be slow, too slow for any single lifetime to perceive. Generations would rise and fade while the galaxies danced, their changes measured not in decades, but in epochs. This quiet patience belongs to eternity. The story of Andromeda's approach is not only about two galaxies, it is about the universe itself. It is a reminder that no star city is truly isolated. Over spans long enough, gravity brings neighbors together, weaving them into new forms. Everywhere across the cosmos, galaxies drift, merge and transform. Ellipticals glowing today are the silent proof of unions long past. And so there is a humility in realizing that our Milky Way, so familiar to us now, is only a temporary design. What we see is but one frame in an unending story. In a few billion years its spiral arms will be gone, replaced by a new form altogether. The constellations we know will vanish. Yet the stars themselves will still shine, simply upon a different stage. And if there is a kind of cosmic humor here, it lies in scale. We fret over daily schedules, late arrivals and fleeting delays. Meanwhile, the universe has already set a meeting between two galaxies, scheduled neatly billions of years in advance. There is no rush. The cosmos works with the gentlest of deadlines. So when you notice Andromeda's faint smudge in the night sky, remember what you are gazing at, not just a neighbor, but a promise. A quiet inevitability written into the heavens. The light that touches your eyes began its journey more than 2 million years ago, carrying with it the soft whisper of what is still to come. It is a reminder that all things change, and that change itself can be beautiful, unhurried, and sure. In time, the Milky Way and Andromeda will draw together, and from their meeting a new galaxy will be born, glowing gently in the endless night. Humanity has grown rather good at imagining such futures. From tracing the weather to charting the paths of planets, our computers have become quiet crystal balls, peeking into what tomorrow may hold. And when it comes to the destiny of our own Milky Way, astronomers have used these tools to look billions of years ahead, watching in fast forward as our spiral home slowly drifts into its great neighbor, the Andromeda Galaxy. What these simulations reveal is a story both dramatic and strangely serene, a preview of a performance our descendants may never see in person, yet one we can already understand in graceful detail. The secret behind these simulations is simply physics. Galaxies are not aimless clouds of stars. They are bound by gravity, shaped by the invisible skeleton of dark matter, and guided by the momentum of their own paths. Every star, every drifting cloud of gas, every hidden halo of unseen matter is quietly tugged and pulled by gravity's gentle hand. To simulate a merger, astronomers begin with what we know shapes, masses, velocities, and feed it into powerful machines. Then, like a spell cast in silence, they let Newton's and Einstein's equations unfold. What appears on the screen is not imagination, but the mathematics of the universe itself, weaving its story through time, and what they see is astonishing. Andromeda does not crash violently into the Milky Way and stop. Instead, the galaxies drift through each other, weaving in a long, slow embrace. On their first pass, tides of gravity stretch out streams of stars, pulling them into delicate arcs that shimmer across space. Then they drift apart, only to be drawn back again, repeating the dance until at last the two settle as one. The process spans billions of years, unthinkable by human standards, but to the cosmos it is just a natural rhythm, a slow inhalation and exhalation of creation. And here lies something wondrous. Stars themselves remain mostly untouched. We might imagine fiery collisions, yet space is vast. Even within galaxies, stars are separated by such distances that direct crashes are vanishingly rare. Instead, they slip by one another, their paths adjusted, their orbits gently rewritten by the changing pull of gravity. For our own Sun and Earth, survival is not only possible, but likely. Perhaps our solar system will drift into a wider orbit or join a long tidal stream, but it is not expected to be destroyed. What Earth itself will be like then is another matter. In 4 billion years, the Sun will glow brighter, slowly warming Earth until its oceans may vanish into steam. Life, if it endures at all, will have transformed or migrated elsewhere. Yet the view of the sky during the merger would be unlike anything we can imagine, a shifting canvas of stars that no human has ever seen. Through simulations, astronomers can watch these transformations in detail. They spin galaxies on screens, colliding and reshaping them in luminous trails of light. Each glowing pixel represents millions of stars, dancing in gravitational harmony. Spiral arms unravel, stretching like ribbons in the wind, until both galaxies lose their familiar shapes. What emerges in the end is not a spiral, but a great rounded galaxy, smooth, glowing, and immense. Astronomers even gave it a name, Milkdromeda, a soft blend of Milky Way and Andromeda. Some call it Milka. Whatever the name, it will be a giant, holding more than 1 trillion stars, shining brighter and spreading farther than either parent ever did. And this is only one step in a much longer story. Dark matter, though unseen, plays its role as well. Vast halos of it surround both galaxies, stretching far beyond the stars we can see. These halos are the first to meet, overlapping like ghostly spheres. Their gravity ensures the galaxies cannot escape, but must merge. Without this invisible matter, they might simply drift past each other like strangers in the night. Instead, they are bound together by chains we cannot see, but whose presence we feel. Nor are they alone in this destiny. The Magellanic Clouds, the Triangulum Galaxy, and countless smaller companions will be pulled into the merger, scattered or absorbed into the new whole. Milkdromeda will not just be the marriage of 2 giants, but the gathering of many voices, folded together into one luminous choir. There is poetry in how simulations reveal this. Billions of years compress into minutes. Galaxies twirl and collide in glowing silence, arms stretching and fading, until only a smooth glow remains. What the human eye could never witness becomes visible on a screen, reminding us that the universe is never still. It is always changing, always reshaping itself into new wonders. And watching these simulations, one cannot help but feel a gentle humility. Here we are, small creatures on a tiny world, trying to peer 4 billion years ahead. Most of us cannot plan 4 days ahead, yet here we are, simulating futures on cosmic scales. From equations scribbled in notebooks to supercomputers humming with endless numbers, we have found a way to glimpse tomorrow's universe. When the Milky Way and Andromeda drift toward each other, there will be no noise, no shattering sound, no audience waiting. The stars will continue glowing as if nothing has changed. Beyond them, other galaxies will go on with their own slow wandering. The dance will unfold in silence, the way it always has, the way it always will. And yet, through careful glimpses of simulation, we've been allowed a preview. We've seen their arms weaving together, their steps so unhurried, their light blending into one. And from that union, Milkdromeda will rise a soft glowing shape against the endless dark. It is a quiet reminder that even the grandest changes arrive not with violence, but with serenity. That in the slow unfolding of time, beauty lingers, patient, certain, calm. By imagining forward, we also learn to rest in the present. The Milky Way, with its spirals and rivers of light, is but one pause in a longer journey. One day, its form will fade into something new. But even knowing this, there is comfort. Stars endure, galaxies reshape. The universe continues its quiet rhythm, whether or not eyes remain to see. In truth, collisions are less rare drama and more gentle constants in the lives of galaxies. To see this, we drift back in imagination toward the young universe newly born after the Big Bang. 13.5 billion years ago, space was tighter, denser, and far more crowded. Galaxies were small and restless, clumps of gas and dust giving birth to stars in a hurried rush. Because they floated so close, encounters were not exceptions but inevitabilities. They were seedlings in a crowded garden, their roots brushing, their branches crossing, their lives entwined. Even now, when astronomers peer into the farthest dark with Hubble or James Webb, they find galaxies bent and misshaped, not broken, not flawed, but alive, caught in the act of change. These uneven outlines are not disorder, but construction. They are portraits of growth, of collisions still moulding the night into grander shapes. Back then, the meetings were not soft. The galaxies were small and thick with gas, and when they met, their clouds collided, pressed close by gravity, sparking storms of newborn stars. Brilliant clusters ignited, some burning fast and ending in dazzling bursts of supernovae. It was a sky of fire, violent, beautiful, unending. Yet from those bursts galaxies swelled, stretching from humble fragments into spirals, into ellipses, into the sweeping giants we now see. Astronomers call it galactic assembly villages, merging into cities, stars gathered into constellations, time stitching one system to another. Every galaxy we see today bears these quiet scars. Peel back their layers, and hidden there are faint traces of what was once devoured, streams of stars pulled from vanished neighbors, whispers of long-ago collisions. Even our Milky Way holds them. Its halo glimmers with the remnants of galaxies it has already absorbed. Astronomers can trace them by the subtle fingerprints in their stars, every galaxy carrying its own unique blend of elements. With these signatures, scientists piece together the Milky Way's family tree. It is a quilt, a patchwork of ancient companions, their light still woven into our sky. Collisions did more than shape galaxies, they shaped the universe. Without them, galaxies might have remained small, scattered like dust across endless space. But mergers drew matter together, forming spirals with graceful arms, ellipticals round and calm, each shaped by the nature of its embrace. From the quiet chaos, the universe drew its variety. Collisions also carried the ingredients of life. The first stars were simple, born of hydrogen and helium alone. But with every collision, stars were pressed into being, and when they died, their supernovae spread heavier elements across the cosmos. Carbon, oxygen, iron seeds for worlds, for oceans, for breath. Without those ancient collisions stirring the sky, the universe may never have grown fertile enough for life to dream. In those youthful days, collisions also fed the black holes at the hearts of galaxies. These giants did not begin immense but swelled with time, nourished by the gas funneled inward during each encounter. When galaxies joined, so too did their black holes, circling, spiraling, until at last they merged, sending ripples through space-time, waves of gravity that drift quietly even now, faintly caught by the instruments of today. The proof of all this lies everywhere. Telescopes show galaxies mid-embrace, spirals tugged by companions, ellipticals polished smooth, their scars hidden but real. Closer to us, streams of ghostly stars arc around the Milky Way, leftovers of galaxies long dissolved. And Andromeda too holds loops and shells, ripples from past encounters. They are fossils of motion, silent memories of the endless dance. The humbling truth is in the measure of time. In the early universe, collisions were fast, each one lasting only hundreds of millions of years. As galaxies grew and space expanded, The encounters slowed but never ceased. Even now, though distances stretch, gravity waits. It is patient. It does not hurry. Looking back, we can imagine the cosmos as a restless child, messy, crowded, filled with energy that refused to be still. Over ages it grew quieter, steadier, yet never motionless. Even now, galaxies drift toward one another, slowly, softly, as if drawn by an unspoken certainty. Perhaps these encounters are not disruptions at all. They are the gentle engines of creation, the quiet reasons galaxies take on their shapes, the silent cause behind the heavy elements glowing within the stars, the unseen hand that made planets and life possible. Every beam of starlight, every breath we take, carries within it the memory of these ancient unhurried embraces. To gaze into the night sky is to witness the outcome of countless encounters, billions of years of slow, patient collisions, woven into the serene galaxies that shine overhead. Their beauty hides a past of turbulence, but it is a turbulence that made harmony possible. Without those early embraces, there would be no spirals to admire, no stable worlds to inhabit, no beings to wonder about their story. Even the most chaotic movements can give birth to order. From the quiet jostling of galaxies, the grand design of the universe unfolded. When galaxies drift together, astronomers speak of sweeping arcs of stars, of rivers of gas, of shapes shifting across light years. Yet beneath that grandeur lies a gentler story, whispered within the lives of stars. Each star, whether caught in the tide of a collision or floating in calm isolation, is bound to the rhythm of its own clock. Its fate is written in the soft balance of gravity, pulling inward and fusion glowing outward. Collisions may set the stage, but stars carry the dance. To rest in the story of stars, we first follow their beginnings. They are born in silence, as clouds of hydrogen collapse under their own weight, warming until fusion sparks in their hearts. For most of their lives, stars remain steady, glowing with quiet consistency. Our own sun has lived in this balance for 4.5 billion years, and will continue for billions more. This stage, the main sequence, is a time of calm brightness, when stars nurture whatever worlds may circle them. Yet nothing in the cosmos lasts forever. Stars too must change. For suns like ours, the next chapter is the red giant. When hydrogen runs thin, fusion slows, and gravity whispers its claim, the core contracts, the outer layers swell, and the star expands into a glowing, swollen ember. It may grow vast enough to consume nearby planets. From afar, it glows deep red, like a fire warming in the dark. Red giants are endings, but also beginnings. As they swell, they shed their outer layers, drifting into space as soft shells of gas, like halos fading into the night. These clouds, lit gently by the star's core, become planetary nebulae, haunting, beautiful veils that last for tens of thousands of years before dissolving back into silence. At their center rests a white dwarf, the quiet remnant of the star itself. Small, dense, and glowing faintly, it cools for billions of years like an ember waiting to fade. None have yet gone fully dark, for the universe itself is still too young. For greater stars, the end is less gentle. They burn faster, brighter, and shorter, swelling into supergiants, vast, luminous beacons that blaze with intensity. When their fuel is gone, gravity closes in, and the star collapses, releasing in a single instant more energy than a galaxy shines in a year. A supernova blooms, scattering the seeds of new life, carbon, oxygen, iron into the quiet void. From this scattering, worlds will one day grow. Some stars leave behind neutron stars, dense as mountains packed into a teaspoon, spinning and pulsing like cosmic lighthouses. Others, heavier still, collapse into black holes, their gravity folding even light into silence. These dark hearts, born of fire, shape galaxies quietly, their influence stretching far beyond their size. Yet even in galactic collisions, Stars rarely touch. They live their lifetimes undisturbed, following their own quiet destinies. But the meeting of galaxies stirs the clouds of gas, sparking bursts of newborn stars, each beginning its long journey. In this way, collisions become catalysts, slow, patient triggers for generations of light. Across billions of years, creation and destruction have danced together. Many of the stars above us tonight were likely born in the wake of such turbulence. Some will end in quiet embers, others in brilliant explosions, but none will end in vain. Every ending gives its substance back to the universe, to become the building blocks of something new. Nothing is lost. Everything is transformed. The atoms in our bodies, the breath in our lungs, were born in ancient stars scattered across galaxies that may have long since merged into something new. To think of stars is to think of continuity, of endings that quietly become beginnings. Nothing fades away forever. Everything returns, reshaped into the cycle. Galactic collisions, then, are less about destruction and more about renewal. They stir the great snow globe of the universe, setting stars adrift, weaving stories together across unimaginable time. Each star is a thread, and collisions are the loom. What feels like an ending is simply part of a larger weaving, more intricate than we can see. The universe writes softly, change is not loss. Transformation is the only constant. For a long time, astronomers believed collisions were simple stars drifting past one another, gas clouds colliding, galaxies folding into new forms. But as telescopes sharpened their vision and maps of mass became more precise, a strange pattern appeared. Something invisible was shaping the dance, something far more massive than all the stars and gas combined. This hidden hand is dark matter, the silent framework of the universe. It does not shine, it does not reflect, it does not absorb light, it cannot be seen at all. Its presence is revealed only by gravity, by the tug on stars, by the bending of light across space, by its quiet grip that holds galaxies together when they would otherwise fall apart. In the theatre of colliding galaxies, dark matter plays the starring role. Without it, cosmic encounters would unfold differently, and the universe as we know it might never have taken shape. The clearest glimpse of its presence comes from a system called the Bullet Cluster, about 3.8 billion light-years away. It is the aftermath of two galaxy clusters colliding at high speed. A single galaxy cluster already contains hundreds of galaxies bound together. When two of these giants meet, they create a natural laboratory, allowing us to watch the unseen scaffolding of the cosmos at work. The Bullet Cluster gave astronomers something extraordinary: direct, observable evidence that dark matter is real. With X-ray telescopes, they mapped the hot gas filling the cluster, glowing as the collision heated it to millions of degrees. This gas makes up most of the visible matter, far outweighing the stars. During the impact, the clouds of gas slammed together, slowing down and piling up like traffic on a crowded road. But when astronomers mapped the mass, using gravitational lensing measuring how the gravity of the cluster bent light from galaxies behind it, they found something astonishing. The true mass of the system had not slowed down. It had passed straight through the collision, gathering around the galaxies themselves. The hot gas was left behind, but the greater weight, the hidden matter, had glided through untouched. This was the inescapable conclusion. Most of the mass was invisible. Dark matter must exist, moving like a ghostly companion to galaxies, shaping their journeys, yet never colliding itself. The Bullet Cluster became one of the strongest proofs of its presence. Quite literally, the visible matter and the true mass had separated before our eyes. Collisions like these reveal a humbling truth about dark matter. It hardly interacts with anything, even with itself. While ordinary matter collides, slows, and heats, dark matter seems to pass through without friction, guided only by gravity. This is why galaxies can cross paths without their invisible halos shattering. It is as though each galaxy is wrapped in a cocoon of shadow, and these cocoons overlap but never tangle. Dark matter is not a background actor. It is the stage itself. Galaxies are seated inside immense dark matter halos, which hold them together and give them form. Without this hidden mass, spiral galaxies would fling their stars away, spinning apart like dough tossed too thin. Dark matter provides the gravity that binds, the structure that steadies, the quiet skeleton on which beauty is hung. Even in collisions, dark matter shapes the script. It guides the galaxies' paths, sculpts the final shape of their union, and frames the new form inside its invisible shell. The elliptical galaxies born of these encounters are written into dark matter's embrace. The bullet cluster is not the only case. Other systems, like the trainwreck cluster known as Abell 520, reveal strange distributions of dark matter, sometimes clumping in unexpected ways, challenging simple models and hinting that its nature may be richer, more complex than we yet imagine. Each collision becomes a new clue, another test in the quest to understand this mystery. What humbles astronomers most is not what is seen, but what is unseen. Dark matter makes up about 85% of all matter in the universe. Everything familiar, stars, planets, clouds, us, makes up only the smallest fraction. We are foam at the crest of a wave, while dark matter is the deep ocean beneath, shaping the swell but hidden from view. Collisions are some of the rare moments when the hidden framework of the cosmos reveals itself. Ordinary matter stumbles and collides, glowing briefly in the impact, but dark matter drifts through without resistance, silent as a shadow, shaping the event only through its invisible pull of gravity. Each galactic collision becomes like a sketch, tracing the outline of this unseen substance, bringing us a step closer to understanding what it is. Astronomers imagine it as particles that almost never touch ordinary matter, perhaps heavy, elusive WIMPs, or maybe feather-light actions whispering across the void. Whatever form it takes, one truth emerges from these cosmic encounters. Something vast, quiet, and unseen is there. Something that steadies galaxies, holds them together, and keeps the universe from dissolving into chaos. Dark matter is the silent architect of the cosmos. It does not blaze in a supernova, it does not form shining stars, and it does not light up the night sky. Yet without it, galaxies would never have gathered. Every graceful arc of starlight, every dramatic tale stretched by gravity, every burst of new stars during collisions, all of it unfolds within a dark matter framework. There is something deeply poetic about this. The most essential force of galactic beauty is the one we cannot see. The famous bullet cluster revealed this most clearly. Gas clouds crash, stars sweep past one another unharmed, but dark matter drifts on, unaffected, steady, strong. It is the unseen partner in the cosmic dance, guiding galaxies through their long, tangled waltz. And so, galactic collisions remind us of how little of the universe truly meets our eyes. Stars may dazzle us, but most of the mass lies hidden, cloaked in shadow. We may never see dark matter directly, but we can trace its hand curving the arcs of galaxies, bending the light of distant stars, and shaping the skeleton of the universe. Even in the violence of collisions, its whisper is steady, guiding, almost eternal. But stars and dark matter are not the only players in this drama. Hidden deep within the centers of galaxies lie giant supermassive black holes. They sit in silence for eons, nibbling gently on stray gas and dust. Our own Milky Way's black hole, Sagittarius Asterisk, is one such quiet diner, faint and calm. Yet when galaxies collide, the table is suddenly set for a feast. Gas and dust are stirred up, tugged inward by gravity, funneled into the waiting mouths of these black holes. They rarely swallow stars. The distances between them are simply too wide. What they crave is the fine meal of gas and dust, and galaxy collisions provide it in abundance. As matter streams inward, it forms a swirling disk around the black hole. Friction heats it to millions of degrees, releasing torrents of energy before it disappears beyond the event horizon. The galaxy brightens with the birth of an active nucleus. Suddenly, a once quiet black hole shines brighter than all the stars in its host galaxy combined. These are the active galactic nuclei, the beacons of the cosmos. Some launch vast jets that pierce through intergalactic space, streams of energy traveling thousands of light years. Others blaze so brightly they can be seen across billions of years of cosmic time. These are quasars, once mistaken for faint stars, but now understood as the roaring hearts of galaxies in their most luminous phases. Collisions are perfect triggers for these outbursts. Alone, a galaxy like the Milky Way tends to stay calm, its rotation keeping gas spread across a wide disk. But when galaxies crash, order dissolves. Gas is shocked, compressed, and swept inward. Black holes awaken, fed by this sudden bounty, and they burn with a brilliance that lights the universe. Sometimes two merging galaxies each ignite their central black holes, creating dual shining cores, a rare but breathtaking sight. Over time, however, the two giants spiral toward one another, pulled closer by the slow friction of stars and gas. In the end, they merge, releasing ripples in space-time gravitational waves that roll quietly through the cosmos, too low for us to hear, but strong enough to bend the very fabric of reality. And yet, long before that final merging, their influence is already felt. The winds and radiation from these blazing black holes sweep through galaxies, shaping the birth and death of stars. Sometimes their fury drives gas away, quenching star formation and leaving behind a quiet elliptical galaxy. At other times, their energy compresses clouds, triggering fresh bursts of creation. Black holes, once thought to be only destroyers, reveal themselves here as co-authors of galaxies, sculpting their futures. Their growth and their hunger are tied to the growth of the galaxies themselves. The larger the galaxy becomes, the greater its central black hole. Collisions are the bridge between them, forging that connection. Billions of years ago, when galaxies were smaller and richer in gas, collisions were frequent and quasars blazed everywhere. Today, the universe is quieter, calmer, but the echoes of those fiery ages remain. Even nearby galaxies, like the antennae locked in their slow embrace 45 million light-years away, still carry the drama of merging hearts, stirring starbursts, and feeding black holes. And one day, far in the future, about 4 billion years from now, our Milky Way will drift into the arms of Andromeda. Their stars will swirl together like glowing streams of light, their gas clouds folding into gentle waves of newborn suns, and deep at their hearts, the black holes will quietly awaken to feast. For a time, this merging may turn our galaxy into something radiant, a quasar, blazing so brightly that its light could be seen across the distant universe, before the two giants finally settle into one larger home. It is a reminder that even what seems like destruction can carry its own kind of beauty. Collisions in the cosmos do not only break apart, they also build anew. At the heart of it all, dark matter, black holes and starlight come together in a story older than time itself. Sometimes, the awakening of a black hole can transform a once quiet galaxy into a beacon, shining across unimaginable distances. And sometimes, it reminds us of something deeper, that endings and beginnings are often just two sides of the same coin. Galactic collisions may scatter and dismantle, but they also trigger the birth of stars, feed the hunger of black holes, and reshape galaxies into luminous new forms. Out of the quiet chaos, brilliance emerges, sometimes so radiant it outshines all else in the night. It is easy to think of black holes as lurking monsters, devouring everything they touch, but in truth, Most are gentle, almost reluctant, resting in silence for eons. Only when galaxies collide do they stir. Only then are they offered their banquet. And when they feed, the transformation touches everything around them. Quasars and active galactic hearts are the signs of this feast, glowing reminders that even the darkest places can, under the right conditions, become radiant. For ages, a black hole may slumber, but when galaxies embrace, it awakens, it grows, it reshapes the destiny of its home. In doing so, it teaches us that even the most destructive forces in the universe can give rise to unexpected brilliance. Galactic mergers, instead of being only violent encounters, are also opportunities, moments where darkness itself writes its story in light. When we picture galaxies, we may imagine them as solitary islands, drifting alone through the ocean of space. But the reality is more tender, more connected. Galaxies live in families. They gather in groups, clusters, and even sprawling superclusters that stretch across vast reaches of the cosmos. A single collision is not an isolated drama. This web is not just poetry, it is real. Through great surveys of the sky, mapping countless galaxies, we see that they are not scattered at random. They trace filaments, delicate strands of galaxies and dark matter that weave through space, meeting at glowing knots where clusters reside. Between these filaments lie immense voids, haunting stretches of almost nothing. Seen from far enough away, the universe resembles a vast glowing spiderweb, galaxies shining in place of dew. Our own Milky Way belongs to a small family called the Local Group, with just a few dozen members. Among them are the graceful Andromeda, the smaller Magellanic Clouds, and many faint dwarf galaxies that circle quietly at the edges. And this little family itself is just a thread in something far larger, the Virgo supercluster. That supercluster is itself only one part of an even grander expanse, the Laniakea supercluster, stretching over 500 million light-years like a continent adrift in the cosmic sea. So, when galaxies collide in our neighborhood, they are not accidents. They are gentle ripples in the larger ocean, in crowded clusters, where hundreds or even thousands of galaxies share the same space. Interactions are constant. Sometimes they are quiet dances, passing brushes of gravity. Other times they are full unions, reshaping everything. The cluster itself, filled not only with galaxies but with vast clouds of hot plasma, adds its own layers of drama, slowing galaxies down, stripping away their gas, and guiding their fates. On larger scales still, superclusters are looser, like vast archipelagos of light. Here too, galaxies drift and merge, though the timescales stretch into incomprehensible lengths. And always, the pattern of the cosmic web endures. What is remarkable is how this web itself echoes the earliest days of the universe. Just after the Big Bang, tiny ripples in matter and energy, so faint they were almost nothing, began to grow under the pull of gravity. Over billions of years, those ripples became filaments, clusters and voids, shaping the structure we see today. Collisions and mergers are simply natural steps in this quiet growth, matter flowing gently along the strands, gathering at the knots, reshaping itself again and again. In this view, the universe feels less chaotic and more serene. Collisions, black holes feeding, stars bursting into life. These are not accidents, but part of a great design. Violence and peace, destruction and creation, each balanced by the other. Even the largest galaxies are just grains of dust within this grand tapestry, woven together by invisible threads of gravity. And it is humbling to realize that we too are born of this web. The Milky Way's history is written with the stories of smaller galaxies it absorbed long ago. Their stars became part of its halo. The elements forged in those stars scattered outward, one day forming the raw materials for the sun, the earth, and eventually for us. To sit here, Reflecting on the cosmos is to be a product of that vast weaving. The web, glowing faintly across the universe, invites more than scientific thought. It stirs reflection. Just as galaxies are linked in unseen filaments, so too are the moments of our lives. A galaxy may appear alone until you see the strands that connect it. In the same way, we may feel solitary until we glimpse the greater web of relationships and histories that hold us. Collisions, whether of galaxies or of ideas or of lives, are not random. They are points of contact, sparks that can lead to transformation and new beauty. In the universe, there is no true isolation, only varying degrees of connection. Galaxies tug gently on one another across unimaginable distances. Clusters gather where filaments intersect, like knots in a vast net, and within those knots, galaxies merge, settle, and shine. The cosmic web is delicate, almost lace-like in its design, and yet it endures across billions of years, fragile in appearance, but eternal in presence. To imagine it stretching across the universe is to feel both very small and, at the same time, deeply comforted. Even collisions, when seen through this greater perspective, lose their violence. They are not sudden crashes, but quiet movements in a larger rhythm. Like waves drifting upon the sea, they are not disruptions, but gentle expressions of something deeper. Galaxies do not collide as enemies. They are carried toward one another by the hidden strands of the web, guided by the quiet pull of gravity that has been shaping the cosmos since its very first moments. In the end, this vast web teaches us about connection. Galaxies may shine, fade, or meet in dazzling displays, but none of their stories stand alone. Each is a chapter in the grand book of the universe, a book where every galaxy is both author and character, and every encounter is a sentence in a story that unfolds over billions of years. Nothing is wasted. Every meeting, every merger adds to the ongoing evolution of the cosmos. It is a vision that is both scientific and deeply calming. The galaxies, strung like pearls along filaments of dark matter, remind us that connection lies at the heart of existence. When we look up at the night sky, the stars are not scattered at random. They are signposts, glowing softly, marking the quiet threads of the web that binds us all together. And within this grand theatre, galaxies are not only dancers in elegant collisions, they are also quiet feeders. While great cosmic unions like the Milky Way and Andromeda take the spotlight, a subtler story often plays out in the background. Astronomers call it galactic cannibalism. It may sound harsh, but in truth it is simply the way larger galaxies gently absorb smaller ones, pulling them apart star by star, cloud by cloud, until what remains is a soft stream of starlight stretched across the night. The universe is filled with these faint, fragile galaxies, tiny companions orbiting their massive neighbours. To a great spiral like the Milky Way, such dwarfs are less rivals and more like delicate offerings. Gravity does the quiet work, stretching and drawing them in, until the smaller system becomes part of the larger whole. This process has shaped nearly every great galaxy in existence, including our own. If you look closely at the Milky Way's faint outer regions, you'll find ghostly trails of stars. They do not belong to its spiral arms. They are the silent remains of galaxies long since absorbed, leaving behind their starlight like whispers of forgotten companions. One of the most striking is the slow unraveling of the Sagittarius dwarf galaxy. Once a loyal satellite, it now drifts apart, stretched into a long ribbon of stars that wraps around the Milky Way like a tattered scarf. With every gentle pass through the Milky Way's disk, more of it is stripped away, until eventually it will vanish into the family of our home galaxy, as though it had always been there. And yet, even this quiet undoing is not violent. The stars themselves rarely collide. They are simply lifted into new orbits, carried by gravity's tide until they are spread thinly across the sky. To anyone living on a planet within those stars, the changes would be subtle. Constellations would slowly distort over billions of years, the familiar night sky shifting in ways so gradual they would feel like dreams. The Sagittarius dwarf is not alone. Other companions, the Magellanic clouds among them, drift nearby, locked in their own slow dance with the Milky Way. Streams of gas already flow between them, pulled away like soft threads unraveling in the wind, and in time, they too may join the Milky Way's story completely, their stars blending seamlessly into the greater whole. On the grandest scales, this quiet consumption has sculpted even the largest galaxies, giant ellipticals, vast, smooth systems at the centers of clusters are the heavyweights of cosmic dining, their halos littered with the faint remains of countless meals. Even our neighbor Andromeda carries within its halo the streams and fragments of smaller galaxies it has already absorbed. This is not destruction for its own sake. It is growth, a slow enrichment. The Milky Way itself would not be what it is without these absorbed companions. Their stars enrich its chemical tapestry, adding variety to its outskirts. Even our own sun may carry the legacy of such ancient mergers, its elements born from stars that once belonged to a different galaxy altogether. So while the word cannibalism sounds harsh, the truth is far gentler. There are no jaws, no violence, no sudden ends, only patience. Over millions upon millions of years, gravity stretches a smaller galaxy into long, delicate streams of starlight until it melts into the embrace of a greater system. It is not destruction, but more like watching morning mist dissolve into the still air. Even here, the universe allows a touch of playfulness. If galaxies were courses in a slow, eternal banquet, the smallest dwarfs would be light appetizers, while great mergers like the meeting of the Milky Way and Andromeda would be the main feast. The Sagittarius dwarf, for now, is a meal in progress nibbled gently, almost absent-mindedly, over billions of years, and when Andromeda finally arrives, it will not be a violent clash, but a vast, slow feast, reshaping two galaxies into one new being. In this way, galaxies are not only dancers, but quiet gourmets forever dining on one another in the dark. Yet what emerges is never waste, only transformation. The stars of smaller galaxies live on, folded into the fabric of larger ones. Cannibalism, in this sense, is not an ending, but a kind of rebirth, where every galaxy that vanishes leaves its light behind, woven into the grandeur of those that remain. It is a cycle as old as the universe itself, repeating endlessly, carried forward by gravity's unseen hand. When we see it this way, galactic cannibalism is not a tale of loss, but of connection. The stars of a devoured dwarf do not disappear. They keep shining, only in a new arrangement, like voices joining a larger chorus. What seems like a cosmic snack is, in truth, a quiet act of creation, the universe folding small stories into its greater one. For the universe has never been still. Gravity, the eternal matchmaker, draws galaxies together, weaving them into dances that last billions of years. Each collision leaves its mark: long streams of stars, great bursts of light, new galaxies born from the embrace of old ones. And when we look far into the future, we see that these mergers are not rare events. They are the very rhythm of the cosmos. Our own Milky Way is already moving towards such a fate. In time it will meet the Andromeda galaxy, merging into something new, sometimes called Milkdromeda. Yet even this will not be the end. Once Milkdromeda has settled into its quiet, elliptical shape, it will continue to gather others. The Triangulum galaxy may join as well, until what is today a family of galaxies becomes a single luminous giant. This story is not ours alone. Across the universe, galaxy groups and clusters follow the same rhythm. Smaller galaxies are gathered in, larger ones merge, and clusters tighten together like the gentle inhale and exhale of a slow, steady breath. On these scales, collisions are not chaos, but harmony, a convergence, gravity, gathering its flock into fewer, greater lights. And so, galaxies do not simply fade. They merge, they reshape, they build. Their encounters are not accidents, but part of the architecture of the cosmos. As the universe grows older, these quiet feasts and dances carry it forward not with sudden endings, but with slow unfolding change. Spirals, ellipticals, starbursts, even the vast clusters strung like pearls upon invisible threads, all owe much of their beauty to collisions. To watch two galaxies merge is to witness evolution in its grandest form, a transformation that shapes structure from seeming chaos. When two galaxies drift near, their unseen halos of dark matter reach toward one another long before the stars themselves touch. This gravitational handshake sets the stage. Slowly, the galaxies stretch, distort, and fling out great tidal tails, long bridges of stars and dust, delicate threads of light tracing the hidden currents of gravity. Sometimes, these encounters ignite starbursts, giving birth to new generations of suns that might never have existed otherwise. Without collisions, the universe itself might have been poorer, fewer stars, fewer planets, perhaps even fewer chances for life to awaken. Collisions also hold answers to some of the universe's deepest mysteries. In their light, astronomers see how galaxies transform from delicate spirals into calm, glowing ellipticals, why some blaze as quasars while others fade into silence, how invisible dark matter shapes all that is seen. Each merger is like a natural experiment, written on scales so vast that only the patience of starlight can reveal the outcome. And beyond the science lies a quieter wonder. Images from great telescopes show galaxies locked in embrace, their arms twined, their cores glowing, their forms stretched into shimmering arcs. These are not pictures of destruction, they are paintings of light and gravity across eternity, each collision a masterpiece. It is tempting to think of collisions as endings, yet stars rarely touch one another, and so most endure. Instead of ruin, there is renewal. Fresh bursts of starlight, galaxies reborn in new shapes, black holes kindled with fuel. Out of collision comes continuation. Even what seems like chaos is part of a higher order, weaving galaxies into ever larger forms, echoing across billions of years. The most profound truth is their patience. These dances last hundreds of millions, sometimes billions of years. What seems a violent clash is in truth as slow and deliberate as a symphony unfolding across cosmic time. To us they are snapshots, a tidal arc here, a luminous core there. To the universe, they are one long, graceful movement, galaxies weaving together in silence. In this patience, there is comfort. Catastrophe, when seen in the span of eons, is only transformation. Endurance comes not by resisting change, but by embracing it. Galaxies remind us of this. They drift into collision with grace and emerge as something new. Even our own Milky Way is not exempt. It, too, is destined to merge with Andromeda, but this is not a cause for fear. The time is unimaginably long, billions of years, far beyond the lifespan of our Sun. Not tomorrow, not in 1,000 years, not even in 1,000,000. The scale is so vast that by the time this slow meeting comes, the universe itself may feel entirely different. And so, rather than fear, we can wonder. The Milky Way will not end it, will become a new galaxy, reshaped, reborn, its stars still shining, its story still unfolding. This is the quiet wisdom of collisions. They show us that even upheaval carries seeds of creation, that endings are beginnings in disguise, that change is not destruction, but transformation. In their arcs of starlight, galaxies whisper to us patience, endurance, renewal. Across eons they drift and dance, unshaken, and as you rest beneath the same sky, you too are part of this great rhythm, a universe that thrives not in spite of change, but because of it.